All right, this problem's a doozy. So, um, you have a fireman standing on a ladder. So let's draw a picture of this, right? I have a fireman standing on a ladder, and I've got a hose that's going up, right? And the hose is changing diameter. Lower end of the hose, this is 10 meters, right? So I know the height, and it has a diameter of 3 inches down here. And it's got a diameter of 2 inches up here, minus 3 inches and 2 inches, right? So the first thing, let's see. Yeah, I got to be in meters per second. The first thing you probably should do is turn inches into meters, right? We need to be in base units. So actually, you know what? No, because I think at the end, the inches are going to cancel out. Yeah, because the area is going to cancel out. So it's okay. It's okay. Right? So we don't need to worry about that. I can leave it like that. But it's diameter. So I do need to cut it in half to get radius, right? So the first thing I'm going to do over here, the area is, this one's 2. So I'm going to go 2 over 2 squared times pi, right? Pi r squared. And then over here, the area is my 3 inches, right? So 3 over 2 squared times pi, right? Just pi r squared. Okay. So now, okay. I'm going to do Bernoulli's equation. So let's write out Bernoulli's equation. So I've got, here's the nozzle, right? So I'm going to call this the nozzle, and I'm going to call this one the pipe, right? So there's pipe, there's nozzle, so that we can keep this stuff straight. So the pressure at the nozzle plus rho g delta y at the nozzle plus the kinetic energy, 1/2 rho v at the nozzle squared, equals the pressure of the hose, or the pump I should say, the pressure at the pump, plus rho g delta y plus 1/2 rho v pump squared. Okay, so I can get rid of down here at the, what is it, at the nozzle, I'm going to subtract that pressure over, right? And I'm going to get rid of the gravitational potential at the pipe, because that's, I'm going to call this 0, right? So I'm going to get rid of this, that's 0. And then I'm going to subtract over the nozzle. So that's going to give me, let's see, 1/2 rho v nozzle squared. And I'm gonna combine the velocities. So I'm gonna subtract 1/2 rho v pump squared, and I'm gonna subtract rho g delta y over to the other side, and I'm gonna subtract the pressure from the nozzle. So I can get all the velocities on one side. So I'm gonna move this velocity to the other side. I'm gonna move these two things over. So 1/2 density times v nozzle squared minus 1/2 density v pump squared equals the pressure at the pump, that's 0, minus the pressure at the nozzle, right? I'm subtracting that over to the other side, so that's gone, minus rho g delta y. Rho g delta y. Okay, so there's where I'm at. Okay, so there's a 1/2 rho in both of these things, right? So I'm going to pull out a 1/2 rho. So that's rho over 2 times v nozzle squared minus v pump squared, right? Just algebra, because I could distribute this in and get 1/2 rho v on both of them, 1/2 rho on both of them. And that equals this, right? And now I'm going to divide by rho over 2. So that equals pressure pump, minus pressure nozzle minus rho g delta y, that's a density. So now I'm going to divide by rho over 2, and that'll cancel that to the other side. So I'll have v nozzle squared minus v pump squared equals, if I divide by rho over 2, that's the same thing as I can multiply the 2 up. So it's 2 times pressure at the pump minus pressure at the nozzle minus rho g delta y over density, right? That's the same thing. Okay, so I can do all of this, and I'm going to solve for Vn squared minus Vp squared. I'm going to get a number. So you can plug in my pressure at the pump. the pressure at the nozzle. Density of the water, density is 1,000. G is 9.8. Delta Y, mine was 10, right? And then divided by the density of the water again, which is 1,000 again, right? It's water. And I can't just cancel that out because I'm multiplying that whole thing by 2. Well, I mean, I suppose you could if you put it in. Yeah, that could cancel out, right? Because it's going to end up being multiplied. Just do it like that. No, you can't, because that distributes. This 2 goes to there and then to that, so you can't. Okay. And then if you notice, it gives you gauge pressure is the pump minus the atmosphere, right? So the pressures I need to use, I've got to take into account that my pressure is, I want the speed of it, it's gauge pressure, right? So the absolute pressure of the pump is 43. So I need the gauge pressure. Okay, so when you're doing that, keep that in mind, right? When you want the pressure at the pump and the pressure at the nozzle, you need to use the absolute values. So for mine, I'm just going to use this number here, right? When I subtract the pump minus the absolute, I'm going to use the gauge pressure of the pump, which is this number it gives me. That number is going to be my pressure of the pump minus the pressure of the nozzle, right? So that number there, that goes in for this little part right here, right? That'll be that number. Okay, so I'm going to get this. And now I need to do something else, right? So you're going to solve for this number. And now I'm going to go look at continuity, right? So I've solved Bernoulli's equation. The problem here is I don't know either of these velocities, right? I'm trying to solve for velocity without either velocities, which is difficult. Okay, so let's go look at continuity. So area of the pipe times the velocity in the pipe equals the area at the nozzle times the velocity in the nozzle. Okay, so let's write this in terms of pi r squared. So pi times the radius of the pipe squared times the velocity of the pipe squared equals pi times the radius of the nozzle squared times the velocity of the nozzle squared, right? All I did was turn A into pi r squared, right? And oh, look, you can see I got a VP squared here and a VN squared here. And look over here. I already figured out what VN squared minus VP squared is. So if I could somehow combine these two terms, I would have a number that I know, right? And that would make solving a whole bunch easier, right? So if I want to get Vn minus Vp, I need to subtract this Vp over. I can't subtract it. I need to, how can I do that? Okay, so I can get Vp over Vn. Let's do that. Got to come up with a way to get over there. So let's do, I'm going to divide velocity of the pipe. Oh, why did I square that? It's not squared. Velocity of the pipe over velocity of the nozzle. I'm going to divide that over, and I'm going to divide the other one over, right? So I'm going to divide by Vn. That's going to cancel that out. I'm going to divide by pi r p squared, and that's going to cancel that out and move it to the other side. So that's going to equal pi r squared nozzle over pi r squared from the pipe. Okay, so that means, right, that my V pipe is equal to V nozzle, right? If I can just multiply this over, it's V nozzle times pi r squared nozzle over pi r squared pipe. And you can see pi cancels out, right? Pi goes away. Okay, so now I've got this. V pipe equals V nozzle times r squared nozzle over r squared pipe. Okay, so I know what, I figured this out up here. I know V nozzle squared minus V pipe squared, right? I know what that is. This is some number, right? So I'm just going to call this, once you know this number, right, I'm going to call this X for what I'm showing you, right? But you would solve this for a number. So just get a number. Like the one I did, it was like 114, right? So I'm just going to call this X. So this is equal to, this number, X, is equal to V nozzle squared minus V pipe squared, right? And V pipe is this, right? So that's the same thing as V nozzle squared. And I'm going to substitute this in for VP. So I'm going to call it V nozzle times R squared nozzle over R pipe squared. Squared, right? VP squared. Okay, so let's distribute the square in, right? So I'll distribute the square. So X is equal to V nozzle squared times, V nozzle squared minus, right? So it's V nozzle squared minus that, minus V nozzle squared times R to the fourth nozzle over R to the fourth of the pipe, right? So I have that minus that times that. Okay, so here we are, right? So I can pull out a VN, right? We're almost there, so close. So I can pull out Vn from both of these. So X is equal to V nozzle squared times 1 minus R to the fourth for the nozzle over R to the fourth from the pipe. Okay, so now I got to solve for V nozzle, right? So from here, right? Okay, let's look at what you know. You know this. You know that number from here. You've already solved that. Okay, so I've got that number. 1 is 1. R nozzle squared, I figured that out, right? So that's this number. That's R nozzle, and I can square it. This is R pipe, and I can square it, right? And I didn't need to convert these numbers from inches because see how I'm just going to divide nozzle over pipe? So the inches are going to cancel out, right? So it doesn't matter. You don't have to convert. So I know this. I can take R nozzle, not squaring it, to the fourth. Sorry. You're going to do that to the fourth. I know that. I know the pipe to the fourth. I can do 1 minus that, right? And this will give me a number. And then I can solve for Vn, right? And so whatever you get, it's going to say V nozzle equals, because it's Vn squared, right? The square root of something. So if you solve this equation for V nozzle, that'll give you the answer. This was the hardest problem on this homework, right? Because you didn't know either of these velocities. So we had to go solve for some crazy thing first. And then we had to take that stupid crazy thing and plug it in down here again, right? So if you got through that and it kind of makes sense, the algebra makes sense, then pat yourself on the back because that was not an easy problem.